To design a flying machine is nothing. To build it is little more. To test it is everything. From defence establishments like Boscombe Down, Bedford and Farnborough, 45 service test pilots daily test military aircraft. This series is about a training school for those highly skilled men. 15 young pilots from the Royal Air Force, the Fleet Air Arm and 9 overseas countries will spend the next 10 months learning to test, flying a variety of aircraft far beyond the normal limits. They are students at ETPS, the Empire Test Pilot School, Boscombe Down. The secret experimental establishment at Boscombe Down is where most of Britain's military test flying is done. But just what makes a military test pilot? The popular image is the man who flies high-performance fighters, like the Tornado. Military test pilots fly thousands of hours to assess new aircraft, new weapons and electronics. Their job is to evaluate the aircraft in different roles, and then to decide whether average squadron pilots could reasonably be expected to fly them operationally. Test flying is not all high-speed glamour. This 30-ton dumper is part of a series of important trials to find out the maximum load that the new Mark III Hercules transport can drop safely. The load is a tight fit going in, and should it jam as it goes out, the Hercules is doomed. Dave Carpenter, the Hercules pilot, is a graduate of the test pilot school. That special training enables him to evaluate the tests in a way that a squadron pilot might not be able to.
This is the last sortie in the trial. We've got the heaviest platform that we've yet dropped. It's 30,000 pounds, and we've got the lightest aircraft weight, fairly light aircraft weight. So we're expecting, with the heavy platform and a relatively light aircraft, to get the biggest, largest trim change on the aircraft. So what we're doing is looking to see if there are likely to be any handling problems or problems to technique that could mean that it would be difficult to clear this particular load for release to the service.
The weather on takeoff is far from ideal, but an improvement is forecast. So the test begins with a 700-foot cloud base, the absolute minimum for the trial. This Hercules is a stretched version of the original, and no one really knows how it will handle as the 30-ton load moves along the lengthened fuselage. Dave Carpenter fits a special gauge, which will measure the forces the pilot has to cope with as the moving load upsets the aircraft's balance. The dropping zone on Salisbury Plain lies ahead in the murk.
100 yards left to line, running power hold at minus 20. Drift is forced over. Right. Moving very slowly at minus 10, 9, 8, 7, 6. Red on, 4, 3, 2, 1, green on, extractor released.
Several slow-motion cameras will record the drop.
Deployed.
The extractor chute draws the 5 main parachutes from the aircraft.
Main parachute's gone, load moving, load gone.
A camera in the cockpit reveals how large an effect the load's movement had on the controls of the Hercules.
There was a peak force of around about 110 pounds. Still, for the very short duration of while the load is moving, it's only a second and a half, 2 seconds. That's not unreasonable, I think.
After analysis, they decided that the lengthened Mark III Hercules could safely drop a 30-ton load, the heaviest to date. All part of the test pilot's day-to-day work, like this VC-10 refueling trial. Once the runways at Stanley and the Falklands had opened, VC-10s could fly direct. But they had to be flight refueled, and since they were never designed for that purpose, a series of trials were flown by the Boscombe Down test pilots.
At high alert weights on the VC-10, we updrift the outer ailerons, as you can see in the aeroplane ahead, to unload aerodynamically in the wingtips. What we are doing now is we are attempting a contact with both the tanker and the receiver ailerons, upset as we call it, and then we will repeat the exercise with them both in the normal position to see if there is indeed any difference from an aircraft handling point of view. Now going over to box 1. Roger. Okay, and red lights out. Okay, buckets coming on. And trimming nose down at all times.
The object of the trials was to write a refueling handbook for RAF VC-10 pilots. The Royal Fleet Auxiliary, Sir Tristram, survivor of Bluff Cove, now recommissioned. A Sea King from the helicopter test squadron at Boscombe Down is to land on the ship, the largest helicopter she's ever had on board. The test pilots will have to decide if Navy pilots can also be expected to land Sea Kings on such a small deck. It may be thought that in this day of computers and simulators, a test pilot's role has diminished from the days of breaking the sound barrier and the exciting new aircraft displayed at Farnborough in the 50s. We asked John Farley, the chief test pilot who did much of the development flying of the Harrier, what is the role of the test pilot today?
Well, I think the job of the test pilot in the 1980s is exactly the same as the job of the test pilot was in the 1920s, or the 40s, or the 60s. I mean, quite simply, his job is to make every aeroplane that he flies as easy as possible to fly, as safe as possible to fly, and as good at doing its military job as is possible. And I think that applies to whether he's flying the first prototype for the company that manufactured the aircraft, or whether he's flying a service acceptance flight at Boscombe Down.
We require in MODPE in this country something of the order of 6 test pilots per year to be trained. That's an average figure, and these test pilots on graduation will move either into the trial squadrons at Boscombe Down or to Bedford or Farnborough.
That is the background to the annual test pilots course at Boscombe Down and the need for a test pilot's school. Competition is keen, and the entry list is always oversubscribed. All the students are hand-picked. They are above-average pilots with recent operational experience. Bob Horton, a Falklands veteran who spent a night in the South Atlantic following a tragic helicopter crash. Robin Tiedemann, Victor tanker pilot. Les Evans, Harrier pilot. And Alan Howden, Royal Navy helicopters. Jim Ludford, who has logged over 1,000 hours on Harriers. These and the other 10 men know that they face months of exacting and at times dangerous work. Why? Why do they want to be test pilots? We asked one of them, Dave Southwood, a pioneer pilot.
The variety of the flying was what really appealed to me, both in terms of the airplanes flown and also the exercises or the trials going on. That squadron flying, after a while, you can end up flying over the same piece of the countryside, flying the same airplane, doing essentially the same things. And test flying offered a great deal of variety. And tied in with that was also a desire, really, to know more about airplanes and about the theoretical side.
The test pilot school, the first in the world, began modestly at Boscombe Down in 1943. From number 1 course to number 44, nearly 1,000 students have been trained, including many from overseas.
I don't know what the the present price of a seat on that course is, but I'd be surprised if it was less than £250,000. And governments don't spend that sort of money lightly unless they think they're going to get some value from it.
Certainly not the French, who have sent Serge Aubert, a reconnaissance pilot. Most of the courses have had roughly half their students from overseas, and number 44 is no exception. J.T. Coe from Singapore, Harry Fay of the Luftwaffe, an F-4 Phantom pilot, Mike Micklejohn, a Canadian helicopter pilot, Mirko Zuliani, who flew starfighters in Italy, and from Australia, Nick Coulson, transport pilot.
Yeah, should be good fun.
Also Tom Coulter of the United States Navy, and Steve Moore, only the second New Zealand student since 1945. The 17 aircraft of the school fleet are made ready. There are 12 types, intentionally varied to provide a wide range of experience. They include this twin turboprop Andover transport, and XL612, one of 2 Hunters which first flew in 1958, but are kept by the school as they are the only swept-wing jet aircraft in the world that are routinely spun inverted. In contrast, 2 Jaguars are flown to give modern high-speed navigation and attack experience. The 2-seater Lightning is for supersonic flying, and this complex aircraft contrasts with the Mark V jet Provost used for initial spinning instruction. There are 2 advanced trainers, British Aerospace Hawks. The helicopter fleet includes a Lynx, Scout, a Wessex, and a Sea King. The rotary wing course runs parallel to the fixed wing. The fitters and engineers work on the aircraft to prepare them for 3,000 hours of student flying.
So that should be done when?
But first, it's ground school, and for most, the dreadful prospect of long-forgotten mathematics.
Well, maths is quite a hurdle for some people, especially if they've only got an O-level, and within about 10 hours instruction, we have to take them from that O-level qualification right through to approximately first-year degree level, in a fairly narrow subject area, but it's still a very steep learning curve. The workload throughout the course is high. There are not many free evenings or weekends, particularly for those that come with a low academic qualification. For those with high academic qualifications, at the early stages, then they have a fairly easy ride, but towards the later stages, they all have a very hard ride.
Though confident enough at the beginning of the course, the workload is severe, and soon some of the students may well be struggling.
Well, I think what happens is, tends to happen, the academic side builds up. It puts a lot of pressure on them. And some people, although have achieved a high standard in flying, are not necessarily the most natural pilots. They achieve the high standard through hard work. Now their hard work is being redirected into the academics, and there's less time to concentrate on the flying. So what you see is a falling of flying standards along with the academic standards, and together the standard goes down. It's a vicious circle.
The first lecture of 250 hours of ground school.
Gentlemen, this morning we're going to start a course on flight control systems. And during this course, we're going to be looking at the F-16 in some detail. I'm going to be using it as an example, not to teach you how to design flight control systems, but to show you the complexity of modern designs. While we should have been seeing an increase in the excellence of the control system.
James Giles, like all the flying tutors at the school, is himself an experienced test pilot.
As examples, one could look at the F-16 first flight, which was in fact never meant to be so. It was a high-speed taxiing trial that got out of control with a lateral pilot-induced oscillation, and the pilot simply put on full power, got airborne and sorted it out. I'd also like to cite the example of a Tornado, which crashed after many hours in service. It crashed on a landing, not because there was any fault in the control system or through any fault of the pilot. The aircraft actually crashed its nose wheel very heavily onto the ground, breaking the airplane because within the software there was a loop that he got into which got pitch acceleration in phase with his stick inputs. All these were examples of aircraft whose designers thought there was no problem. And yet there was, and that's what we're going to try to teach you, to look into those corners of those envelopes in modern flight control systems where you may find problems.
Now, elevator position is most important
in spin recovery. When your elevator is...
Visiting experts are invited. Men like Darrell Stinton, an aircraft designer and civil test pilot, here to give a lecture on spin recovery.
Anti-spin rudder. And this is why we look, during our flight testing, at recoveries with elevator up and also reversed recovery with elevator down.
The subject of today's lecture is a subject dear to all your hearts, differential equations. We've got an example here on the overhead projector, and as you can see, it's a linear, second-order, homogeneous equation, one which you all will learn to know and love. On the chalkboard, we've got some examples of linear differential equations, starting with an undamped mass spring damper system, and for the electronic engineers amongst you, this is an electrical circuit. And this one, of course, you'll all be familiar with. It's Newton's law of cooling, which says quite plainly, the hotter you get, the quicker you cool down. And I'm sure you all want to do some further reading on this fascinating subject, and I can recommend this book, Mathematics for Engineers by Dull. It's the sort of book that when you put it down, you can't pick it back up again.
Well, the ground school itself is, again, a lot of work. It's a lot of reading, and the subject matter is not fantastically complicated, because we've got a very good tutor here who can put it over quite well. The problem is the volume. There's just so much of it. Because as you can imagine, the whole aviation subject is absolutely vast, whether you're talking about aerodynamics on a helicopter, engine design, goodness knows what. And there's just so much that you've got to try and take in during the course. And I reckon it's going to take me at least another year after the course is finished to reread all those notes. As you can see, there's a whole row of them over there. For a lot of guys, like myself, all failed their A-level maths, and that was about 12 years ago when I was at school. And of course, suddenly being confronted with quadratic equations and calculus was really mind-blowing. It was very difficult.
Not all the students pass. We hope that our selection procedure will give us students who are likely to pass the course, but one can never be sure. And there are two real stages of the course where people get into difficulties. And one is on adaptability, on the flying side. You mentioned that we could be converting or could be flying somebody in the Jaguar who had only experienced heavy aircraft, and vice versa, fighter pilots encountering large aircraft like the Andover and the BAC-111 for the first time. Now, in the first few weeks of the course, we deliberately expose the pilots to a large number of types to check their adaptability. And we don't give them long conversions to the aircraft, we give them minimum conversions to the aircraft, showing them that they can adapt quickly to different aircraft, that basically they're all the same, and provided they know the fundamental differences, then they can cope with the sort of flying that's required. Now, the problem is that some people are not able to rush from one aircraft to another. And unfortunately, those sort of people cannot really be employed as test pilots.
Always at the back of both tutors' and students' minds is the question of how a man, however good a pilot, will stand up to the searching role of being a test pilot. A role never called dangerous by the services, it is, however, conceded to be high risk. Are test pilots supermen, or mere mortals who can, like the rest of us, experience fear?
If they don't, they didn't ought to be test pilots. I mean, fear is a very, very necessary thing. I mean, my word, yes, if a chap doesn't have the greatest respect for any aeroplane he is flying, not just testing, but just flying, then he didn't ought to be an aviator. I mean, it's a very unforgiving environment, the air, just like the sea is. No, you must be frightened. You must know your limits, you must know the aeroplane's limits, and if you come close to both of them, you must be frightened. Otherwise, your chances of being successful or avoiding an accident must be greatly reduced.
The first lying on the course is converting the students, who have flown a wide variety of aircraft with their squadrons, to the school fleet. For even a student test pilot has to be able to fly any of the school aircraft without conscious effort. a bit like riding a bicycle. The Hawk is an advanced trainer, and the two on the school fleet will be used in many of the exercises. In contrast to the high-speed Hawks, the Basset, one of the few piston-engined aircraft the students will fly. This is no ordinary dog of war. It is unique and was specifically adapted for the training of test pilots at Boscombe Down. The French student Serge Aubert is to fly an exercise in the Basset, normally considered to be a most inoffensive machine. But this one, at the press of a button, can become difficult and bite. James Giles.
Well, what we use it for is as an airborne simulator. It is exactly that. We can actually take the classroom theory and let the student fly this aircraft to bring the theory into practice. We've had it now since 1972, and it's been a very useful tool. And what it does is essentially, through a computer, it modifies the behavior of the Basset, and we can make it fly like, essentially like any other aircraft that we want to make it fly like, within the restrictions of the fact it is a Basset.
So the control column there is really not connected to anything other than the computer?
That's right. This control column is just connected to the computer. There's an input from it measuring the pilot's force that he applies to the control column. So once the student flies this, and you can probably see that the existing aircraft control column isn't moving at all. And all he does is he puts his inputs through this. They're then modified by the computer, which in turn essentially flies the aeroplane. To change the configuration, that is the way the aircraft flies, what we have to use, as you can see down here, is rows of analog, we call them pots. Simply by changing the number set on them, changes a resistance in the analog computer, which varies that particular aerodynamic response. We can actually make it apparently unstable. As far as the student's concerned, it's still a stable aircraft because it's still a Basset, the host aircraft, but we can actually make it appear to the student as though it's unstable. So we can put him in a potentially dangerous situation, in an apparently dangerous aircraft within the existing safe airframe of the Basset.
For safety's sake, the Basset is not allowed to be flown via its computer below 3,000 feet. So the tutors perform all takeoffs and landings using the aircraft's conventional controls. Once above 3,000 feet, the student takes over and the exercise begins.
Right, Serge, what I'm going to show you now is a high yaw to roll ratio. And that means we're going to get a lot of yaw and not much roll. What I mean, I want you to roll out onto a heading.
This exercise is to give Serge experience of a common aircraft handling fault, the Dutch roll.
So normally we'd expect a Dutch roll to damp out well, nice and controllable. You have control of the aircraft and the computer. What I want you to do is put a small rudder doublet in, and then holding the stick central, just have a look at the natural response of the airplane as it comes around. And as you can see, it's gradually getting divergent, and there's the system cutting out, saying that probably the aircraft would have crashed had that been allowed to continue. Okay, have you rolled out on 330?
I rolled out, anticipate about 7 degrees. It took me about 4 inputs in L1 input to try to stabilize the Dutch roll. So it requests...
The Basset had been programmed to handle as a badly designed aircraft. Its ability to do this within the limitations of the airframe makes it an invaluable teaching aid.
Because the Dutch roll was excited, we saw the heading change, and certainly an HQ on 4, unsatisfactory. We'd like it to be much tighter than that.
Much tighter?
Yes. Okay. Things to remember about the Dutch roll. Firstly, there is a damping ratio, which is how quickly the motion dies down. There's a frequency, which is the speed of the motion itself. And there's the roll to yaw ratio, which is a measure of how much roll, how much bank angle to how much side slip. And those are the 3 aspects they have to assess. And they're all important in their own way.
The 44th fixed wing course runs parallel to the 23rd helicopter course, with a good deal of interchange. But the rotary wing students have their own specialized training, and like the fixed wing pilots, they will have to develop a wide range of advanced flying skills. Mike Butt is the qualified helicopter instructor. He and his student, Andy Tailby, are preparing for an exercise to land the Scout in a very confined space. This is a conversion flight, for Andy is an experienced pilot. He flew the only Chinook helicopter to leave the ill-fated Atlantic conveyor minutes before that ship was hit by an Exocet missile during the Falklands War. The Scout is obsolescent. It has largely manual controls and a shortage of power, making the confined space exercise difficult. And the visibility is not very good either. But operation helicopters in Army service have to be able to land where they're needed.
Well, we're just about dead into wind at the moment, and it's getting pretty bumpy. Obviously that's going to help the power on the way on the initial approach, but certainly not when we actually get into the trees. It's going to be quite turbulent, so to be aware of the control response and the yaw limitations on this thing as we run into the final descent.
There will be one low pass over the top there to identify the particular clearing. At the same time, in fact, we can also peruse the surrounds, shape, and also the surface inside.
Roger, okay.
Okay, if I had to come round to the left now fairly sharply. Clearing is down, reach down there.
Okay. I didn't get a particularly good look at it then.
Okay, all looking around, there's no aerials.
The exercise is to test the limitations of the helicopter, not the test pilot, who will be taught to set aside his special skills and to ask himself, could this be done by a squadron pilot on operations?
Forward one. Forward a further one. And left one.
The figures are in meters.
Yeah.
I'd like to go tail there.
No, not really.
Okay.
No, we've got a high, very high tree. You have to come to the left.
Okay.
Bring the tail round to the right. Okay, vertical coming down. All clear this side. All looking good. Well clear
Loads of clearance on this side.
Right over the pad.
Okay, all right at the back there.
Okay, well clear behind. Sending on. All looks good. Okay, come left one in the hover. Left two. Left one. Steady. Okay, back one. Back one. Back a further one. Okay, steady there. Steady there. Clear down.
Yeah, it looks all right on my side.
Okay, no further forward.
As course number 44 gets underway, 15 young men will learn a great deal about aircraft and even more about themselves. For the next 10 months, they will have to work harder than they now think possible. But at the end, they will have the skills to test an aircraft they have never flown before to its and their own limits.